triangles, certain things are marked, certain side lengths are given to us, and what we're really trying to do is determine whether these triangles are similar, and if they are, we'll write a similarity statement for it. If the triangles are similar, there's two things that we have to look at. One, the angles in both triangles have to be congruent with one another. And then two, the side length ratios must all be the same. Okay, so first let's look at the angles. Here I've got one angle that matches up with this one. It's got one arc on it. Here we've got two arcs that matches up with two arcs, and three arcs that matches up with three arcs. Okay, so in terms of the shape made up by the angles, those angles are all congruent. That's our first step. We're saying yes, there's still the possibility of these triangles being similar. So now let's look at the ratios of the side length. So really I've got three sides here. I'm going to put my fraction bar. I'm going to say I hope that first fraction is congruent with the second fraction, and so on. I like to set it up in advance. So let's look at, we'll keep all the larger triangle side lengths on the top, as the numerators. The smaller triangle we'll put it on the denominator. All right, so let's just take a look at this first side over here of 10. Okay, 10, which is side CD, corresponds with one of these sides. There's a couple ways to look at it. I could say, well, it's in between the angle with the one arc and the two arcs. Okay, so here's the one in between one arc and two arc. It must match up with 8 because of that reason. The other way I could look at it, in the terms of the three sides, I've got the smallest side, the largest side. 10 is really my middle length. And so if I'm going to match it up with a side here, my smallest side, my largest side, 8 is in the middle. That's another way that I can figure out which sides really correspond. Okay, so 10 over 8. Let's take a look at this next one. Let's do 5. 5 is the smallest side here, so it must match up with the smallest side here. Again, we could also say it's in between the second and third angles, two arcs, three arcs. And then finally we've got 12 from the large triangle, and we're going to have that correspond with 9.6 from the smaller triangle. So again, in order for these triangles to be the same, all the angles have to be congruent with one another. They are. And then all of these side length ratios must be the same. Well, 10 over 8 is really the same as 5 over 4. It is really the same as 12 over 9.6. And if you want to simplify all of those, I guess you could. You could even turn them into decimals if you wanted to. This is probably going to be the easiest one, where you say, well, that's 1.25, that's 1.25, that's 1.25, if you just divide them. Okay, so those are all going to be the same, which means we've got two triangles that are similar. So now the last thing that we want to do is just write a similarity statement. So I'm going to look at that first triangle and say, we'll call it CDE. Triangle CDE is similar to the smaller triangle. Be careful though, we got to make sure that first letter of C matches up with the first letter here. C was the one with one arc on the angle, so I'm going to match that up with T. D corresponds with the next letter. D was the one with two arcs, so I'm going to match that up with U. And then finally E must go with V. That is our similarity statement. Triangle CDE is similar to triangle TUV. I know that because all the angles are the same and because the side length ratios are the same.